Hello everyone, today we're going to reverse engineer an inducer and impeller within CFturbo. Inducers are necessary for the design of a pump whenever cavitation is an issue. To start off, we're going to select the pump module on the left-hand side. Then we're going to input a design point. So you'll need a flow rate, whether it be volumetric flow rate or mass flow rate. Then you need some energy transmission value, whether it be head or total pressure difference, and then a rotational speed. After you input these three values, CFturbo calculates a specific speed. In this case, we have a specific speed of 16, and then that points to a general machine type that you should use as a starting point. So this points to a centrifugal high pressure impeller. And then you can go ahead and click OK. In the CFturbo main GUI, rather than starting from scratch, you're going to go down to Existing and select Import Geometry. Under Import Formats, you're going to select Reverse Engineering and ensure that the component type is set to Centrifugal Pump Impeller. And then select Import. We are now within CFturbo's Reverse Engineering GUI. On the top left-hand side, you can see the steps that is required of the reverse engineering process. We have import, meridian, and blade. I will go over all three. On the left-hand side, this is where your CAD data, faces, and solids are located. In the middle is the 3D view of the imported geometry, and then on the right-hand side is a settings bar that's related to whatever step we are on in the reverse engineering process. To start off, we're going to select Load CAD Data. We're going to find the geometry that you'd like to import. And then on the left-hand side in the CAD data tree, we're going to open up the solid faces so you can isolate each face. Since we're starting with the reverse engineering of the centrifugal impeller, I'm going to select the faces that correspond to the inducer and set them to be invisible. There's two ways you can do that. You can, on the left-hand side, uncheck each box that is correlated to the face, or in the imported geometry 3D window, you can right-click and set invisible. After we import the geometry, we need to align it. We want the fluid to enter the positive Z direction and exit in the XY plane for a centrifugal device, so that's properly aligned. If it wasn't, you would just select a face, and then on the bottom left-hand side in the transformation panel, you can translate, rotate, scale, mirror, or align a face to a Z-axis. In terms of rotation direction, we read the rotation direction from the shaft side. So when fluid enters this impeller, the blades will be rotating clockwise from the shaft side. So you want to ensure that right clockwise is set in the rotation direction here. The second step is meridian. In addition to the CAD tree and the imported geometry 3D view that we had previously, we now have a redesigned geometry 3D view and a meridional contour view of the hub and shroud contours. And then we have new settings on the right-hand side. So with this, we want to select the surfaces that represent the hub and shroud and map to hub and shroud. So if I select this surface, click map to hub, and then I select the shroud surface, click map to shroud. Okay, so let me open this up a bit. In the redesigned geometry, we now have our own CFturbo surfaces for hub and shroud overlaid with the selected CAD faces. And then down here, we have just the meridional contours of both of those surfaces. If it was an unshrouded impeller, you would just select this, define a blade tip clearance, and then rather than mapping to shroud, you would map to blade tip. The third and final step is blade. So in this step, we're going to map the blade surfaces to the blade. So let me go ahead and make my life a little bit easier by setting the shroud surface to be invisible. Okay. And so then I'm going to select the leading edge, the pressure and suction side of the blade, and then the trailing edge of the blade. You only have to do one blade. It would be redundant to do every blade. And then I'm going to click map to blade. We have 6 blades here, so we don't have to set, this value to anything else. If you have splitter blades, this is where you would check that. In this case, we don't. Number of spans, offset hub, and offset shroud. This is whenever you want to play around and try to better match your redesigned geometry to your imported geometry. Number of spans, whenever you have kind of highly twisted blades, you might want to play with that number. For offset hub and offset shroud, this comes in handy whenever you import a geometry that has blade fillets. And if you want to kind of bypass the effect of those curvatures, you would maybe offset the hub or offset the shroud a little bit. And then in terms of blade edge shape, this is where you define your leading edge shape and your trailing edge shape. In this case, we have a rounded leading edge and a blunt trailing edge, so we can actually just leave that. And so in our redesign geometry window, we're going to take a look at our redesigned geometry overlaid with our selected imports and just see if there's a good match, if we should play around with it anymore. It's looking good, so I'm going to go ahead and click OK. And then we're shot back to the original CFturbo GUI. On the left-hand side, we're going to right-click this component, select active. Then I'm actually going to rename it. Let's rename it component 2 impeller. I'm going to do a component 2 because we're going to have eventually an inducer in front of this. Okay, and then I'm going to select 3D model. And then here we can see our redesigned geometry overlaid with the original CAD file. And it's looking like a good match. Okay, so for the inducer, I'm going to start from a new CFturbo design window. Okay, so for the inducer, I opened up a new CFturbo design window. We're going to click pump. Same thing, we're going to input the same design point and select OK. Then again, I'm going to go down to import geometry, ensure reverse engineering is selected under import formats, and then for component type, we're actually going to select axial pump impeller, then select import. Again, we're going to load the CAD data, and we already know that the CAD that's imported is already aligned properly, so we can go to the second step, meridian. And then we're going to ensure that unshrouded is checked, and I'm going to input my value for blade tip clearance. In this case, it's 5 millimeters. And then I'm going to select these surfaces that represent the hub and click map to hub. And then I'm going to select one of the blade tips and click map to blade tip. Okay. And then in the meridional contour window, we're going to have to define an extension that would kind of nullify this intersection here. So if you right click this, click define extension, and you can type in a z value of -331. And then I'm actually going to define extension on the hub side, -331. Okay, great. So this just provides kind of a flat inlet for the fluid to flow through. And then we're going to define an extension at the outlet, extend to a z value of 0. And then we are going to go to our third and final step, which is blade. Okay, so I'm going to select the surfaces that represent one blade. Grab that one. And then the trailing edge. And then I'm going to click map to blade. And then we're going to ensure that we have 3 set for the number of blades. Number of spans, 6 is fine. This offset hub, offset shroud, we're going to leave at the default values of 3. And the shape at the leading edge and the trailing edge is both rounded. So we're good to go. Then I'm going to open up this redesign geometry window and just see how it compares to the original. It's looking pretty good. I'm going to click OK. Same thing, I'm going to go to the left-hand side, click Activate. I'm going to rename this as component 1 underscore inducer. And then I'm actually going to read in the component to impeller by selecting this plus button. Click Import CFturbo Components. Go to the CFturbo design file with the component to impeller. Select this component. Click OK. It says overwrite the current design point with the imported one. They both have the same design point inputted, so this ultimately doesn't matter. Okay. And then let me change the color of this to components as orange, and then do that again. And then I'm going to go down to the imports, right click that, and I'm going to add a transparency. To 40. Okay, so now we can see the CFturbo design file overlaid with the original CAD. It's looking like a really good match. There's some warnings that I want to address. So let's start with that. Okay, so the first warning I'm going to address is this flow outlet does not match next inlet, and the flow inlet does not match previous outlet. Those are connected. So I'm going to ensure that the inducer is selected, go to main dimensions, go to dimensions, and then at the very bottom here, you can match the outlet dimensions to the neighboring component. So I'm just going to click outlet and select OK. And that warning goes away. Next up is this global setup. This energy transmission of all impellers is different of globally defined value. So basically this is saying that because we define 225 for both the head, 225 meters for both the head of the inducer and the impeller, it's saying that both are designed to reach that value independently. But in reality, we want the inducer to have 5 meters of head and the impeller to have 220 meters of head. So if we go to main dimensions of the inducer, go to setup and go down to multi-stage options, change this value from 225 to 5, click enter, and then at the top, we're gonna select, or rather deselect manual dimensioning, and click OK. And then we're going to go to the centrifugal impeller, go to main dimensions, setup, and then rather than having 225 meters of head, we're gonna do 220, select enter, and then click OK. Okay, so that value, that warning goes away. And then for the swirl gradient violates Euler equation, we're going to go to the inducer, go to blade properties, go to blade angles, and we just have to recalculate our beta B2 values now that we know that this is only responsible for 5 meters of head. So click calculate beta B2. Our Euler velocity triangles look a little better now. We're going to click OK. And that goes away. Now we have a new warning that says blade angles beta B are different compared to the blade properties. So one thing that you'll have to do is go to blade mean lines, right click any of these mean lines and select Bezier curve. So we're converting these values, these lines from polylines to Bezier curves, there's going to be some discrepancy between the two. But now our warning goes away. We're going to click OK. Okay, great. Okay, so now I'm going to click 3D model. We have a fully parametric, reverse engineered CFturbo design file overlaid with our original imported geometry. So this is great whenever your company has legacy designs that you want to maybe update, provide some manual adjustments to, or do more robust optimizations. CFturbo can provide a starting place for that to do baseline CFD and then update and optimize your future designs. Thanks so much for listening.